Bismillahirrahmanirrahim. In this session, we will discuss definite integration, that is exercise 15.8 from additional mathematics course for IGCSE and O-level students. This definite integration, we called it definite because of some limits. So there is the upper limit and a lower limit. So this A is a lower limit and B, small b, is a upper limit. So we have to evaluate this integration within this limits. So this FB and FA, we insert the limit, upper limit and then lower limit with the subtraction. So similarly for this k fx dx, in this k is constant and fx is write down like this. So this can be solved. And similarly for this fx plus minus gx dx, this can be separated like this independently. So let's solve exercise 15.8. So start exercise 15.8. Number of questions are there, so we'll solve one or two. So evaluate the integration with some upper and lower limits. And similarly for the second part and third part, let's solve this exercise. Question number 1a, we have to find this 7x power 6 dx. So this 7 is separated here, and this x power 6 can be written down as x plus 6 plus 1, and this then in the denominator 6 plus 1. So this is basically n plus 1, and n plus 1 is in the denominator, and the integration are 1 and 2. So these are the limits. So this is 6 plus 1 is 7, 7 cancel out. So this x power 7, 2 power 7, and then 1 power 7. This is 128 minus 1, and this is 127. Similarly for this 4x power 3 can be evaluated easily. This is 4, and this is x power minus 3 plus 1 minus 3 plus 1. So this is minus 2, cancel out. This minus 2 is here, and then denominator x power 2. So substitute limits. This minus 2 can be placed here, and on substituting limits values, we obtain this 3 by 2 and 1.2. Similarly for this h part, we have this 1 3 and 2x power square minus 1 x power 5. This can be written down 2x power 2 and divide by x power 5. So x square and x5 cancel out to obtain x power 3 and 1 over x minus 5. So now integrate this part, we obtain this. On integrating this part, we obtain this, and limits, on substituting and placing limits, we obtain this result. So this is simple. Similarly for this one, on multiplication, we obtain some values and then integrate every part. Integrate this part, and on integrating, we have obtained this value. So 75.5. Similarly for this k part, we have this v1 2 5 minus x 2 plus x x power 4. On multiplication, we have obtained this. On simplification, we have this, and then separated out each part, simply integrate and substitute the values. So this is all, and we have obtained this answer. This is very easy. Similarly, the cell part. And now question number 2, we have this a part is 1 2 2x plus 1 power 3 dx, and we have to integrate this one. So this 2 will be here because of this 2, and 3 plus 1, this 3 plus 1 is there, 3 plus 1 is here, 1 to limits, and this is 3 1 4 2 8. This is 2x plus 1 power 4 limits, and we have obtained this result. Similarly for this part, 2x plus 4 dx, integration, we have this part is 2x plus 4 half plus 1 divided by this 2 is here and then half plus 1. Integrating with 0 to 6, simply substituting values of limits, and we have obtained 18 2 by 3. Similarly, this e part minus 1 to 1 to 3x plus 5 over plus 2, so dx, so this 2 will become minus 2 in the numerator, so this 2 is here and this 3 is here. 3x plus 5 minus 2 plus 1 and then minus 2 plus 1 denominator, so we have this. On simplification we have obtained this. On substituting limits we have obtained this. This is question number 2, and in the next session we will discuss